What you are about to witness is a fractal morph that's unlike anything you've seen before. The idea came to me after watching a wonderful video by 2Swap, which was about Mandelbrot's evil twin. It's an amazing video, and I've put a link in the description so you can enjoy it after you finish this one's. But his video also made me think about a problem. 98% of the fractal journeys we see are zooms. Incredibly deep zooms from galactic sizes to scales smaller than an atom. And they're great, don't get me wrong. But once you've seen a few, the magic repeats. However, fractals hide another behavior, for me, much more interesting. Morphing or metamorphosis. If you adjust the parameters with extreme care, you can achieve transformations that seem organic, alive, almost alien. The problem is that it's a very meticulous process, and the programs I've tried either aren't designed for this or didn't give me the freedom I was looking for. So, like any good geek with a problem, I decided that if the tool I wanted didn't exist, I'd build it myself. The first step was to choose a canvas. Mandelbrot and Julia are very explored. I wanted something different, and after much searching, I found a fascinating one. The Zubita fractal. And no, don't try to look for it on the internet because you'll hardly find any information about it, which made it even more exciting. The basic Mandelbrot equation is this: z equals z squared plus c shra. In the Zubita fractal, an apparently simple change is introduced. C is also divided by z. dz equals z squared plus c divided by z shtai. This small division changes it at its root. This is what a basic Zubita fractal looks like, rendered with my program and processing. Beautiful, right? But now, to bring it to life, I needed to control its parameters in real time. The first thing I did was link two of its variables to the mouse position. And it works nicely, but moving the mouse manually is imprecise. So I automated it, making the coordinates move in circles. I added two new parameters: speed to control the rhythm of the change, and diameter for the amplitude of the movement. Now came exploring part. I spent days looking for combinations of parameters that would create interesting behaviors. And every time I found one, I saved it as a preset. With a good collection of presets, only the last step was missing: linking them. I wrote a small algorithm that creates smooth transitions between one preset and the next, interpolating all its values with a cubic ease in and out. This creates a fluid and almost infinite choreography of shapes. This is where everything comes to life. Fractals flow into each other, like creatures made of mathematics. And after all that work, the software, the exploration, the presets, the transition engine, the final result is this. Turn up the volume, get comfortable, and enjoy the ride. During the exploration phase, while I was writing and refining the code, I stumbled upon a hackathon featuring interesting equations beyond Zubiedas. Naturally, I explored them and plugged them into the Fractal Morpher to see the results. I'm attaching some renders that I liked. These equations don't have an official name. To me, they resemble fried eggs. I thought it would be a shame not to share some snippets here for you to see. I don't want to be the only human who has witnessed how these galactic fried eggs perform their fractal dance. And that's it. A small demonstration that fractals are much more than infinite zooms. They are a universe of artistic possibilities waiting to be discovered. If you liked the video, hit like and subscribe for more experiments like this. And don't forget to check out the Cellflow video that started this series of creative programming. The link is in the description. Thanks for watching until the end, and see you next time.